This video is sponsored by Envato Elements. Hey everyone, and welcome back to another very exciting Blender tutorial. Today we're finally going to get into geometry nodes. First off though, if you want to skip all of my waffling, you can jump straight to the tutorial, and there's going to be timestamp links down for you in the video description for that. But it might be useful to know that geometry nodes, which were first introduced in Blender 2.9, give you a procedural way to create or modify the geometry in your scene. Similar to the shader editor, that unlocks a humongous amount of creative possibilities, and if you search Twitter, Instagram, Snapchat, Reddit for geometry nodes, there's some amazing stuff that people have been creating with them. Now, geometry nodes are not the easiest thing to get into, and so I want to make a little bit of a tutorial series for how to use them because I've been having a ton of fun with them. This video is going to cover geometry nodes for absolute beginners. Now do note that this is geometry nodes for absolute beginners, not Blender or computers or the internet for absolute beginners. And I would assume that you are familiar with the basics of how Blender works. If you're just getting started with Blender, I've got a full tutorial series that I'm going to link you down below. And if you don't like that, you can always just go for the donut. Before we jump into it, I want to give a big shout out to Envato Elements for sponsoring this video and helping me pay the bills. Envato Elements is a massive online resource offering over 55 million digital assets to kickstart your next creative project. They have everything from graphic and video templates for your favorite tools such as Premiere Pro, After Effects, DaVinci Resolve and others, to stock footage, graphic elements, music tracks, sound effects, 3D models, fonts, website templates and a ton more. They're offering a really simple licensing model that gives you full commercial rights to any asset you download, with some reasonable clauses like you can't resell them of course, and this license remains valid even after your subscription has ended. You can sign up to either a monthly or an annual subscription, both giving you access to an unlimited number of resources across all of the assets, and I'll drop you a special link down in the video description that will give you 50% off if you choose the annual plan. And if you're unsure, why not try it out and sign up for a free account? You get 12 free assets every month and you can upgrade your plan at any point you want. But now, talking about sweet baked goods before I waffle on forever, let's jump right into the tutorial. Let's get into Blender, and the first thing that is important to note is that I am using Blender 3.1. Now, geometry nodes changed quite significantly in Blender version 3.0, so it is important that you use version 3.0 or later. Version 2.9 is going to be a little bit out of date by now. But now let's get my ugly face out of here and let's jump into the tutorial. I have a brand new empty scene here, and the way geometry nodes work in Blender is via modifiers. So with the default cube selected, over on the right hand side, come into the properties panel and select the little wrench icon here, which is the modifiers tab. Let me make that just a little bit bigger, and I'm also going to zoom in a little bit, so hopefully you can see that a little bit easier. Let's click on Add Modifier, and the modifier I want to add is Geometry Nodes. Let's click on this, and this is going to add a Geometry Nodes modifier to this particular model in my scene. Now, right now, nothing has changed, but that's also because we haven't actually done anything in this geometry node yet. For that, we need to use the Geometry Nodes editor. And by the way, up here in the top, there's a layout specifically to working with geometry nodes. So let's simply click on that. And what you'll get is in the top right-hand side, you've got your 3D view, so you can see what's going on. In the bottom, you've got your geometry nodes, and that's similar to the shader graph. It's a node tree or a node graph that we're going to be working with. Right now, it doesn't really have much other than the default input node and the default output node. And in the top left-hand side, you will find the spreadsheet. This one is super useful to look at the data that actually flows through your geometry node tree at any point in time. Right now, there isn't much in here other than you can see there's a mesh here with 8 vertices, 12 edges and 6 faces. Also, let me zoom in just a little bit more. And this is essentially just the geometry of our cube right here. And now, in this geometry nodes editor at the bottom, we can add a whole bunch of nodes to transform our geometry from the simple cube into anything we want. We can create new geometry, do proximity testing, change color, distortion, add noise, animation, whatever we want. It's a really nice procedural way of working. And all of this is going to be saved in a modifier, in a geometry nodes modifier that we can then apply to any other object in our scene as well. And it will receive the same processing, the same transformation. In order to make it a little bit easier to reuse our geometry nodes modifier, let's just click on the name here in this modifier panel. And let's call this one my first geometry node tree. And let's start actually doing something. So Geometry nodes have an input, which is the geometry that gets fed into it, which is essentially the geometry at this point in time when it hits this particular modifier here. All it has is a single input, which is your geometry. This represents the input geometry into the geometry node's modifier. That then gets fed into the output, so we're outputting that same geometry. If you click on this little green circle here at the end, click and drag, to disconnect this line, or just let go anywhere and disconnect that, your cube will vanish because now, well, we still have an input, but we're not actually outputting any geometry at all. You can also see that the spreadsheet editor in the top left-hand side now shows nothing because there's no more data that comes out of our geometry node tree. In order to reconnect this, simply left-click onto the geometry input on the left-hand side and drag that over to the right-hand side into the group output. And our cube is back, and we can see the final evaluated data for our geometry node tree in the spreadsheet editor. Now, this is pretty darn boring and a million miles away from all of the cool stuff that you can see people have created online with geometry nodes. So the magic with this comes in the fact that we can add new nodes to this tree to modify this geometry or create new geometry, extrude, animate, do whatever we want. But let's start out simple. Now, with the cursor over the geometry node editor, Shift and A to add a new node. And in here, you'll find a ton of different nodes that all have different function and purposes to transform, calculate, do maths, proximity, all sorts of cool stuff. You can also come up into the top menu on the geometry node editor, click Add, and in here you'll find the same list. If you're ever not sure what any of these nodes do, in the official Blender 3.1 manual, which I'm going to link you down in the video description, you can find all of the different nodes. And if you click into any of these, there's a description of the node, what it does, what all of the properties are for. There's a humongous amount of detail to dig into. And again, I'm going to keep it pretty simple in this one. Let's return back to Blender. With the cursor over the geometry node editor, Shift and A, let's add a new node. And you can dig through this if you know, but let's come up into search, click into search, and let's search for set position. Let's click. So now we've got this node, and similar to the shader editor in Blender, you can drop it on a connection line right here. So let's drop it right on this line that connects our input to the output and drop that in. So now we've connected this node to process our geometry and output the result of that. But we're not doing anything right now. So again, we're just stuck with the same boring default cube. However, set position now has an offset property. And if you click and tweak any of these values, sure enough, that offsets our cube. A couple of really useful shortcuts, and again, I'm a stifler for shortcuts, so try to learn them all, they're super useful. With the cursor over any node in your tree, you can press M to mute it, which will essentially disable it and just kind of feed the geometry right through, so that's disabled the effect. Again, press M while you're hovering over it to re-enable it. Press H to collapse them, or H to expand. And again, it can be really useful if you have a very complex node tree and you just want to, just collapse a couple of things to make it simpler. You can also group things together and create grouped inputs and outputs and all sorts of fancy stuff. But again, let's just leave this as it is. X, as always, will delete it, but it will also delete all of the ingoing and outgoing connection on that node. So let's press Ctrl or Command and Z to undo that. If you press Ctrl and X, that will delete the node, but retain all of the connections. So it reconnects the inputs and outputs accordingly, so you didn't have to do that yourself. And as always, you can also just right click a node and you've got all of these options in here. But again, shortcuts are a winner. But now let's finally get to something just a little bit more interesting, because right now all this position property does is just translate our cube and just changes its position. It's pretty boring. However, you may notice that all of these properties also have inputs. These inputs are diamonds, whereas the geometry, for example, is a round circle. Now, a round circle in geometry nodes means that it is discrete geometry or discrete values. There are two different types of flows in any geometry node tree. There's a data flow, which flows left to right. So right now, from our group input, the geometry, which is a discrete set of information and data, flows from the left to the right, joins into this set position node, which does some magic on it. And then the output of that flows into the group output, and that flows left to right. However, anything that's a diamond is actually a field. Now, fields are essentially functions that Blender can call upon whenever it needs to calculate a value, and this function flow in geometry nodes actually works backward. However, in order to explain that, let's do something funky. Let's change this offset here from a fixed value to a random value. For that, Shift and A with the cursor over the geometry node editor. Again, if you know where they are, you can just dig them out of their respective folder. I'm just like going to search, So let's search for random, and the node I want is random value. Click. And now to place this node, let's place it down here at the bottom. And you may notice that the output value here also is a diamond. It's actually a function that gets output that can calculate a value. It's got a min and a max, as well as a random seed and IDs for object and instance selection and all sorts of other stuff. But let's just change the type from float over to a vector, which has an x, y, and z component, because the offset I want to drive with that on our set position node has an x, y, and z property as well. And now let's connect this value. Just click and drag, connect that into the offset. And now your cube is all messed up. The reason for that happening is because set position actually sets the position of every single point, every vertex on your cube. And the way it does that, geometry uses a data flow. It flows left to right. So the geometry comes left to right to this set position node. The set position now tries to set the position of every vertex on that cube. In order to do that, it needs to go and get an offset value. However, it will call this value for every single vertex independently, which means every vertex gets its own independent offset. So essentially, it hits set position, but then goes backwards to calculate the offset and use whatever we connected down this end on the function part to get an actual value. If this random value was also flowing left to right, means that this would only be calculated once, and then every point would be offset by the same random value, but every single point gets its own random value because the offset gets evaluated right to left in this function flow. That is distinctly different, and you don't need to know and understand all of the details, but it has some interesting implications. There are a few things you need to work around, but it again opens up a humongous amount of possibilities. Plus, it's a whole lot more efficient to actually evaluate this tree. So that looks quite interesting, but it's a bit plain. What if we subdivided this mesh a little bit more? Now, you could go into the modifiers tab on this cube and add a subdivision surface modifier right here. But we can just do that in the geometry nodes directly. So again, cursor over the geometry node editor. This time I'm going to come into add, search. Let's search for subdivide. And I don't actually want subdivision surface. I actually want to subdivide the mesh, which is going to subdivide the edges faces without actually, lerping it and making it smooth. It's just going to introduce additional geometry. So let's select this node. You can see it's green as well, and it's got a green round mesh input and a green round mesh output. And we can drop it right after our group input here. And now we've subdivided this cube, and the set position node that happens after that now, again, gives every single vertex its own random position. Let's disable the set position for just a second. So hover over set position, press M to mute that. You can see the cube is back. However, if you go into wireframe, you can see this cube is now subdivided. And as you increase the level parameter on the subdivide mesh node, it gets more and more subdivided. Let's just leave this maybe on level 3. Let's re-enable set position by pressing M while we're on it. And you can see everything gets very mangled up. Let's return to solid shading mode. And it's just getting too distorted. So let's tweak our random value a little bit. Maybe let's lower the max to 0.2, 0.2, 0.2, and that looks a little bit more normal. Let's actually just zoom out with the cube selected S and just scale that up just a little bit more so you can see the detail without having to zoom in all too much. And so now our geometry nodes modifier turns a cube into this kind of distorted subdivided mesh. In the modifiers tab, if you disable this modifier, the geometry nodes won't be applied and we'll just have a simple cube. But if you enable it, this is the effect of our current geometry nodes tree. Now again, it's not super exciting, so let's add some new geometry within our geometry node tree. For that, let's press Shift and A to add a new node, hit search, and search for the instance on points node. Let's select that, and I'm going to place it at the top. It's a little bit bigger. And this essentially instantiates an object that you have in your scene on all of the points. Now, the points right now for our cube are all of the vertices. So what I'm going to do is I'm going to actually connect this points input on the instance on points to the subdivided mesh. Let's take the output of this mesh, and you can connect them to as many nodes as you want to, and to connect that up to the points for the instance on points. And let's take the instances, the output of this particular node, click and drag, and let's connect that to the group output, so our geometry node output. now our geometry has vanished and nothing is being output. And that's because the instance on points actually wants something to instantiate on all of the vertex points, which we're not doing. So the output of this is actually 386 instances, but they're just points. There's no actual geometry data being output. If you hover over these green circles, you can actually see geometry is 386 instances. At the end of our subdivide mesh, if you hover over that, you can see it's 368 vertices, edges, and faces. But we now need to actually instantiate something. For that, let's add a sphere. And again, you could create that in your 3D scene, but why not just do that in geometry nodes? So Shift and A, let's add another node. Let's do search. And let's search for the icosphere. We'll to just drop that in here. And by the way, these socket values won't actually be evaluated until you connect them into the tree. Again, it's a performance thing with Blender. So let's connect this mesh into the instance on points. And yes, that looks like something, but it's all overlapping geometry. The reason for that is just because the radius on our icosphere is a bit too big. Let's just shrink that down to maybe 0.08 or anything that makes you happy. And now you can see we're outputting all of these icospheres. I'm actually going to increase the subdivision on them just to make them just a little bit smoother. But it would be nice if we could still see that original cube that we had in our scene. Now, we can easily output multiple pieces of geometry in geometry nodes by joining them. And for that, there's a node called Join Geometry. So Shift and A, search. Let's search for join. And there's this node here called Join Geometry. Let's just again drop that on this connection that already exists to our group output. Nothing has changed so far, but you may notice that this geometry input on this Join Geometry node is actually a bit bigger because you can connect as many geometry pieces into this, and this node is going to just join them all together. So now let's take the output of our set position node, this geometry, and feed that into the input on our Join Geometry node. And yeah, kind of, except that the icospheres are being generated based on our original subdivided but non-distorted mesh, whereas the mesh itself that we output is the output of this set position node. The way to fix this now is to use the output of this set position node, which outputs this distorted mesh, as the input into the instance on points, so that we're using the offset points on our cube to instantiate our icospheres. So let's grab the output of set position and connect that to the points input on instance on points. And now all of the icospheres are again placed on the vertices of our distorted cube. Really nice. Now let's come to the very top and return to our layout workspace. And here we have our cube. Let's just select it, press delete or full stop on the numpad to zoom in on that. And that looks pretty cool. And all we really have on it is our geometry node modifier. However, wouldn't it be great if we could modify some of the properties of our geometry node graph directly here? For example, how much distortion we have or how subdivided that mesh gets. Fortunately, we can do that with geometry nodes. So let's return to the geometry nodes workspace. And in this group input node, which represents all of the inputs into this geometry node tree, right now we're just getting the geometry. But you may notice that there is actually an empty socket here, and we can give this node as many inputs and extra values to ingest that we need within our tree as we want. So with the group input node selected, over on the right hand side in the geometry node editor, you'll find this little arrow poking out to the left. It's absolutely tiny. You can click on that to expand this panel here, or you can press N while you're hovering over this editor to pop it in and out. Now let's go into the group tab, and in here you can see the inputs and outputs of this particular node setup, this group here that we're working with. Right now the inputs is only one geometry input and one geometry output, but let's add some more inputs. The two things I would love to control is A, the amount of subdivision we have on the mesh, like this level property, as well as the distortion we're getting on our cube and maybe the size of the icospheres. So let's add a new input by clicking on this little plus icon here on the right hand side in the group tab. Now we don't want that to be geometry, so let's change the type over to be a float. So let's say we're going to do the radius for the icosphere first. In the modifiers tab, you can see there's now this new input, geometry, that has appeared here. Its value is currently 0. It's also called geometry, which doesn't make sense. Let's call this one sphere radius. You can see the name being updated in the modifier. So now we have an input called sphere radius. Default 0, min probably 0. Max can be infinite. That's fine. let's add another input here for subdivisions. Let's call it subdivisions, and let's change the type from float over to be a discrete integer value. Minimum, again, let's set that to 0. Let's add yet another input, change the type over to be a float, and let's call this one distortion. In the modifier, you can now see we have a sphere radius, subdivisions, and distortion properties as inputs. And in our geometry node tree, if you now zoom into this group input, you can see you now have these inputs, geometry, but we also have sphere radius, subdivisions, and distortion. The cool thing is you can now wire these up to wherever you want in your tree. What I'm going to do is I'm going to click onto the sphere radius, drag that, and connect that to this radius input on the icosphere. All of the spheres have disappeared, but that's because on our modifier, the sphere radius is set to 0. So if you now increase this value, you can control the size of those spheres. Let's connect the subdivisions into the subdivisions level on the Subdivide Mesh node. And all subdivisions are gone because, again, our subdivisions level is 0 right now. So let's press 1, 2, maybe 3. So 3 levels of subdivision. And now distortion. Let's wire up distortion. And the cool thing is, even though our random value is actually a vector with a vector for the minimum, like 3 components, and a vector for the maximum, you can actually click and drag this distortion, which is a single decimal value, and connect that, for example, into the max. And the same value will just become the x, y, and z of that. Again, we have no distortion here, so let's just drag that and decrease this just a little bit. And you can see the cube distorting. And by the way, you may notice that the distortion kind of happens towards the right here because we're only increasing the max. We're only distorting in the positive x, positive y, and positive z direction. We're never going negative. And it's just a little bit weird. So let's just set this to maybe 0.1. And now I can't just connect the distortion to the minimum either. But what I would love to have is I would love the minimum to just be the negative of the distortion. So if my distortion is 0.1, my max is 0.1, but my minimum should be minus 0.1. Again, we can just wire that up, but we need another node, which is super handy. You'll use tons of them, and that's the math node. So again, with the cursor over the geometry nodes editor, Shift and A, let's add another node and search for the math node. Let's just drop that down here on the left-hand side. Right now it's an add node, but if you pop down this drop down here, there's actually a ton of functions, a ton of things you can do to calculate on the fly in geometry nodes, and you can create some really funky stuff with this. Now what I want to do is I'm going to select multiply. I'm going to drag the distortion input, connect that to the top value on my multiply node. The bottom one, I'm simply going to change to -1. So I'm just going to invert that number. And the output of that is now going to go into my minimum on the random value. So now my distortion, if I lower this or increase this, happens uniformly in all directions. Now I probably don't want to jack it up too much. Stuff will get a little bit weird, so maybe let's leave it at 0.1 just so we can see the effect. And the awesome thing with this particular setup is that now if you returned to your layout workspace where you don't have the geometry node editor, you can just select your model that has your geometry nodes applied to them, and you can change all of these properties right here on the fly. You can also change them. Ooh. Just make sure that you don't increase the subdivisions too high, otherwise it can just freeze up Blender and crash your computer. I wish they would put a bit of a safeguard in there that Blender would ask you after 30 seconds of processing going, are you sure you want to continue, or just abort the operation altogether. But now we have the ability to control the subdivision numbers. Let's turn that to 3, as well as that size of the icosphere and the distortion directly from our layout panel. Let's return to the geometry nodes workspace and let's make this a little bit more interesting. What if I wanted to scale the spheres based on the amount of distortion of the vertex that they're attached to? Right now all of the spheres are the same size and, well, it's nice, it's a little bit less interesting. Now, the radius itself requires a discrete value. It can't be a function. So I can't actually, unfortunately, stick this value here from my random value into the radius. If you try to connect those two, it will actually go red because the radius is requiring a distinct value. It can't go back to then calculate a random value, and that's not going to work. So let's click and disconnect that random value. But what we can do is instance on points has a scale property. So we can actually take this random value output and stick it into the scale value on the instance on points. Now the spheres are still there, but they're very, very tiny. And we're now also ignoring the sphere radius property. So what do? Again, let's use some math. So Shift and A, search. Let's add yet another math node. And I'm actually going to drop that directly on this line that connects the random value with this scale property here. That's going to automatically be wired up for me. Let's change this from add again to multiply. And let's grab the sphere radius input and drag that to be our second value. Let's let that go. And the spheres have gotten even smaller. But let's jack up the sphere radius here on our modifier. Cool. That looks pretty nice. And now the spheres are scaled based on how distorted that vertex is. So if we increase the distortion, you can see the spheres get bigger. If you decrease the distortions, the spheres get smaller. And just a bit more of an interaction of all of those elements. And you'll find that as you work through geometry nodes, you just keep tweaking things. You just add things in and just add more interest, add animations, colors, all sorts of weird things, and just play around and have fun and just see what the result is. Just be aware that if you add, like a subdivide node that suddenly subdivides 20 times, it might produce too much geometry and Blender might simply freeze up. So be sure to save frequently. Also, let's just take this set position node and just drag that up a little bit, move the multiply down just to kind of make that just a little bit easier to read, maybe just like that. And yeah, I don't quite like the distortion. It just looks a little bit awkward. So instead, let's just add extrusions to all of these faces that we've subdivided so they kind of poke out straight rather than being a bit of a distorted mess. So let's add another node into our geometry node tree. Let's search for extrude. And I'm going to add an extrude mesh in here. I'm going to drop this node directly after my subdivide mesh before set position. And whoa! That looks pretty interesting, but also a little bit messy. So I'm actually going to delete this set position node here. And again, if I deleted that, all of these connections would get lost. So let's press Ctrl and X to delete it. That's just going to wire that right back up. So now we have extruded all of the faces on our subdivided mesh, but it looks a bit boring because they're all being extruded the exact same distance. So let's grab the output of this random value, and we can just leave this on a vector, even though technically we can change it to a float as well. Grab the output of that. Actually, let me zoom in just a little bit more. Let's grab the output of this random value and let's stick that into the offset scale property on our extrude mesh. And so now all of these faces are being extruded differently. So if you now increase the distortion, you can see that all of these extrusions change. Let's pump this up just a little bit, but let's make the sphere radius a little bit smaller. And I don't like that the spheres are kind of on the corners. They're just on the vertices. I'd rather have them like literally right in the middle of these faces. That would likely look much nicer. For that, we need to replace this instance on points to place those instances on the center of these faces. Fortunately, there's another node for that. So with the cursor over the geometry nodes editor, Shift and A, search, and let's search for points. And again, there's quite a few different operators and nodes in here that you can use. The one I want to pick is mesh to points. For now, I'm just going to drop it at the top here, so we can rewire our instance on points. So now the output of this extrude mesh, which right now goes into the points property on instance on points, I'm going to pump that into the mesh itself. The output of this mesh to points is now going to be my points input. But now on this mesh to points property, I don't want to create a point for every vertex. I actually want to create a point for every face. You can now see the spheres are sitting in the middle of these faces. However, I only want to do that for the faces that are pointing outwards from the extrude. And the way to do that is a lot of these nodes have a selection property that allows you to control which elements, in this case, which faces, actually get converted into points. The cool thing is that the extrude mesh node has an output for top and side selections. And these ones are essentially all of the top faces or the side faces of that extrude operation. So I can now wire the top faces of our extrude operation into the selection onto the mesh to points function. And now you will only have the spheres on the faces pointing outwards due to that extrude operation. And this looks much more interesting and much more intentional. But of course, feel free to tweak this geometry node tree to your liking and just play around and have some fun. There's, again, some cool stuff that you can do with it. Now, the last thing I want to show you how to do is how to add some animation, because right now, if you return to the layout workspace and drag the bottom up to reveal the timeline, if you play this back, There's no animation. There's nothing happening here. It just looks a little bit dull. So let's return back to the Geometry Nodes workspace. And what I want to animate is this distortion here. Now, obviously, the strength of that distortion I want to leave as an input parameter, but I kind of want to animate this to go from 0 to whatever that distortion value is, kind of in and out, kind of in a breathing rhythmic pattern. Now, on this random value node, you have a seed, which changes the seed and the set of random values that get generated. You can click and drag through this, and you can see that that changes our effect because it changes the random values that get generated by this node. But this looks just really erratic, and it's not good to animate this at all. Instead, let's introduce a sine function and change it so that it goes from 0 to 1 in a curve, like up and down breathing movement, and use that value to drive the distortion in and out. So in our Geometry Nodes tree, first off, Shift and A, let's search for, again, it is the beloved math node. Drop that in, change the operator from add over to sine. And if you now connect that value to all of the places where right now the distortion is connected, so for example, the input on this multiply node, and Blender tried to be smart and swap those out. Let's just disconnect the distortion right here, and let's connect this value also to the max on the random value. And if you now shift this value property, hold down Shift if you want to change it just slightly, you can now see this creates animation because we're actually animating the distortion that gets applied. However, I still want to use the input distortion. So again, we need to create another math node, change that over to multiply. Distortion comes in on one side. The value of the sine output goes into the other side. And now the output of this node will feed into the multiply node that inverts this value to be used as the minimum. Again, let's disconnect the old node, and the output of those operations becomes the maximum. So now this sine controls the animation itself, but the distortion is still useful in controlling how much of that distortion happens. So if I lower the distortion, that animation is a whole lot slower. Let's come to the bottom here, to this horizontal line, just underneath the scroll bar on the Geometry Nodes editor. Right click, create another horizontal split, drag that up, and change the view over to the timeline, just so that you can see what's happening here. If you scrub through, nothing happens. And you could technically now keyframe this value property, but there's a really cool shortcut in Geometry Nodes, and I think you can use this in all sorts of other places in Blender. Let's click into this value and type hash frame and enter. This is going to use the frame number as a value. So on frame 1, it's 1. On frame 2, it's 2, 3, 4, 5, 6, 7, etc., etc. And if you rewind and play this back, it's way too fast. So let's come back to frame 1, click into this value. Again, it's our frame, but now let's go divide by 10. So you can literally put mathematical operations into these values. Hit enter. And now if you play this back, cool, that looks pretty good. The only thing I don't like is that it goes negative. So you can see right here, it's 0 essentially, but then it goes negative and the extrusions happen inwards, and it just looks a little bit weird. I'd rather just have it happen in one direction, but again, you can leave this if you're happy with it. But what I'm going to do is I'm going to remap, because the sign goes from -1 to 1, and I really just want this value to go from 0 to 1, so the distortion is always positive. Now, you can use math nodes to do this, but there's a really useful helper node that I really like to use. So Shift and A to add a new node, hit search, and let's search for map. And I want to use a map range. So let's click on that. Let's drop this node right after the sine output. And this essentially just remaps a certain range coming in to a certain range going out. I know that my sine goes from -1 to a maximum of 1, and I want to output that as a new 0 to 1. So it's just remapping that. So if you now rewind, let's disable the clamp on that as well and play this back. Nothing at all happens, and that's because my min is really -1. Let's rewind and play this back. Cool, that's looking really nice. Let's return to the layout here. Let's reselect our cube, and in the modifier stack, let's increase the distortion just a little bit and jack that sphere radius up. just a tad. Let's rewind and play this back. And I'd say that's a pretty cool effect. The awesome thing with geometry nodes is that you can easily reuse them. So let's grab this cube with G, move it to the side. Let's shift an A, let's add another mesh. Let's add a Suzanne monkey. I'm just going to rotate that a little bit, face up, scale it up, G and Z, move it up just a little bit like that. And now with the monkey head selected in the modifier panel, I can add a new modifier. Let's once again add a geometry nodes modifier, and this would add a new one, but I can actually use this drop down here, pop this open, and select my first geometry node tree, which is the geometry node setup that we just created. Works similar to reusing materials with shader editor. So let's select this. By default, nothing happens, but that's also because our radius, subdivision, and distortion is nothing. So let's increase the distortion. You can see the effect happening right there. Maybe I'll jack the subdivision up by 1. 2 is a little bit too noisy, maybe just the 1. And let's jack up the sphere radius as well. So maybe 2 or 3. Zoom in just a little bit. Let's rewind and play this back. And that's a pretty funky effect. Now there's still a ton we could do to make this look a whole lot better, like adding noise to give it a bit more of an organic pattern and change some of the details, fix some of the issues with this. But hopefully this was enough to get you started with understanding what geometry nodes are and how to use them. And hopefully you get excited about just playing around with them, experimenting and just having some fun. And that is all there is to it. I really hope you enjoyed this tutorial, and please don't forget to like and subscribe if you would like to see more. All and any useful links you will find in the video description, and please leave any comments, questions or suggestions down below. And with that, thank you very much for watching, and until next time, I will see you later.